Welcome to section 3.3, Deployment Patterns. In this lesson, we'll explore how AI models are delivered into production systems. We'll look at the three primary modes of deployment: batch, online, and edge. Each has unique benefits and constraints that impact latency, cost, and scalability. By the end of this lesson, you'll be able to understand batch, online, and edge deployment models, compare benefits and constraints of each approach, learn rollout strategies for safe deployment, and connect deployment choices to real world scenarios. So, batch deployment. Batch deployment executes model inference on large sets of accumulated data at scheduled intervals. This method is highly efficient when immediacy isn't required. For example, generating overnight fraud risk scores or weekly customer churn reports. By processing data in bulk, batch systems maximize throughput and reduce costs compared to continuous real-time systems. The trade-off, however, is delayed feedback. If users need predictions instantly, batch deployment isn't the right fit. Still, it remains a powerful pattern for analytics, forecasting, and large-scale reporting tasks where timing is flexible. So online or real-time deployment. Online or real-time deployment provides predictions immediately when requests are made. This is the foundation of applications like recommendation engines, chatbots, and fraud detection at transaction time. The primary strength is responsiveness. Predictions arrive within milliseconds, enabling interactive and personalized experiences. To succeed, online deployment requires scalable infrastructure, including load balancing, auto-scaling, and constant monitoring. The trade-off is cost and complexity, since maintaining low latency performance across millions of requests demands significant resources. Organizations choose online deployment when user experience depends directly on real time. Edge deployment runs models directly on local devices, such as smartphones, IoT sensors, or autonomous vehicles. By eliminating round-trip communication to the cloud, latency is drastically reduced. Edge deployment also supports privacy since sensitive data doesn't leave the device. This makes it ideal for voice assistants, factory equipment monitoring, or self-driving cars. The challenge is resource limitations. Edge devices have restricted compute power, memory, and storage. To succeed, models must be optimized through techniques like pruning or quantization. Despite these constraints, edge deployment is critical where low latency, privacy, or offline availability are priorities. So comparing deployment modes. Each deployment mode serves a different purpose. Batch deployment is efficient and cost-effective, but delayed, making it best for analytics and scheduled predictions. Online deployment enables real-time interaction, but demands powerful infrastructure and higher costs. Edge deployment minimizes latency and enhances privacy by running locally, but device constraints limit model complexity. Many organizations use hybrid approaches. For instance, training centrally, deploying online APIs, and running lightweight models at the edge. The right choice depends on balancing latency, privacy, cost, and scalability against business requirements. So safe rollouts, canary deployment. Canary deployment is a cautious rollout strategy. Instead of releasing a new model to everyone at once, it's deployed to a small subset of users, the canary group. This minimizes risk, since only a fraction of users are affected if problems occur. Performance is monitored carefully, and if results are positive, the rollout expands. If issues are detected, the system reverts quickly to the previous stable version. Canary deployments provide a practical way to test new models in production without exposing the entire user base to potential errors. Blue-green deployment. So blue-green deployment runs two parallel environments, the current version in blue and the new release in green. After the green environment is validated and tested, traffic is switched from blue to green. If problems surface, rolling back is immediate. Simply redirect traffic back to blue. This approach virtually eliminates downtime and ensures smoother transitions for mission-critical applications. The main drawback is cost, since maintaining two full environments require additional infrastructure. However, for organizations where availability and reliability are top priorities, the benefits far outweigh the expense. And then finally, A/B testing. A/B testing splits user traffic between two versions of a model, typically the existing one and a candidate replacement. This allows real-world performance comparisons across statistically significant user groups. For example, one half of customers might receive recommendations from the old engine, while the other half sees results from the new one. Key metrics such as accuracy, engagement, or revenue are then analyzed to determine which model performs better. A/B testing supports evidence-based decision-making but must be carefully designed to avoid bias and ensure fair comparisons. So to summarize, deployment determines how AI models deliver value in the real world. Batch deployment is efficient but delayed. Online deployment provides real-time responsiveness, and edge deployment supports low latency, privacy-preserving use cases. Each has trade-offs in cost, infrastructure, and complexity. Safe rollout strategies, canary, blue-green, and A/B testing, provide controlled ways to release new models with minimal disruption. Together, these approaches allow organizations to deploy AI with confidence, balancing innovation with stability. Thank you for joining me in this lesson. Until then, till next time.